Okay, so now I'm going to present the work package 6, which one tries to serve a portfolio level analytics tool suite. Okay, here we involve Tetra and also Suite 5 with Kostas Totsakis. This tool suite is composed by 4 applications. Now I'm going to only name these applications, and after we are going to go in much more detail of all of them. The first one is called Portfolio Analytics and Management Application. The second one is Flexibility Analytics and Consumer-Centric DR Optimization. The other one is called Personalized Energy Analytics Application. And the last one, DR Smart Contract Monitoring, Handling, Settlement, and Remuneration Platform. Okay. The target users here, we are trying to cover retailers, aggregators, and building prosumers. We are also working with the Synergy platform, as Angelina said in Work Package 5. The main functionalities of Synergy platform, we can say that we have a marketplace where we can buy different data sets provided by the stakeholders or different users. These data assets can be bought through blockchain. We can also create different pipelines in terms of data preprocessing. We can also define different training artificial intelligence models. And also we can schedule different pipelines just to achieve or obtain different live artificial intelligence models inferencing, okay? This another aspect important of the Synergy platform is we can also see a principal dashboard, a main dashboard, sorry, that let the user have a brief overview of all the data sets and different statistics in terms of pipelines, okay? Another principal asset that of Synergy platform is that all stakeholder data available in a centralized platform, and more or less pretty much is this. Moving to the key innovations, this work package is trying to cover to fit into aggregators and retailers high value information to better position themselves in day ahead and intraday electricity markets using novel deep learning strategies. We are also finding great management and control of portfolio flexible assets on the way to ensure a win-win situation for both aggregators and flexible asset owners through a participation of flexibility services. We are also fit into building prosumers high-value information to enable a proper balance between comfort and energy savings. And by the end, state-of-the-art marketplace environment for aggregators and flexible asset owners, ensuring the transparency and fairness through a blockchain network established to handle the contract and settlement process. Okay, so moving to the first application, which one is called Portfolio Analytics and Management Application. This one has as a target users retailers and aggregators. And as a main focus, we are trying to exploit all available data to analyze and detail what is the composition of the portfolio of customers and their behavior. We're trying to let the target users gain useful insights towards segmentation of customers and enable global strategies to address the energy requirements of the portfolio. We are also trying to minimize deviations between customer demand and energy allocated in the wholesale market. And finally, we're trying to optimize the target users' transactions using accurate demand and generation forecasting models, allowing to better position themselves in the ahead and intraday electricity market. Okay, here you can see some slides. I saw some screenshots of the application, but I'm going to show it by a live demo. Okay, is this one. Now I'm here. I'm going to show you. We have a login form. We're also using here my credentials, which ones are related here with the Cuerva company. Okay. Two first main sections and are related with the forecast models. We have two types of forecast models, which ones are related with energy demand and the other one to the energy exported. For each of these two types, we have a short-term demand and a long-term demand. The first one tries to forecast the next 24 hours, and the long-term demand tries to forecast the next year in a monthly granularity, okay? Here, Right now, we are working only with 6 customers of the portfolio from Cuerva. We can see, for example, if we select one customer and we select one time period, we can see the historical real demand values and also the prediction for these next 24 hours, the last ones. Okay, we are letting also the user download the resource as a CSV file, okay, just to manage this resource. We have the same for the generation. In this case, in terms of generation, we are only working with the PV from Calahorra. We can also see the historical values compared with the forecast. In this case, we have a generation. In the demand, we don't have generation because we don't have enough historical data. So we are waiting for retrieve more historical data just to add this new model. In this case, moving to the long term, we can click here and we have all the prediction for the next year since now of our model. Perfect. The next section is the portfolio patterns here. We can have pretty much the same as the previous one in terms of historical data, but here we can also see the portfolio complete demand, and we can also see the historical data of the complete portfolio, just to give to the final user more information regarding the complete portfolio. Moving to the portfolio profiling, here is where we are making different segmentation of this customer portfolio. The first one, we're trying to create elasticity profiling. We have created 4 groups in terms of elasticity, and we can also check the details of each group and the different KPIs of each group. Okay. Moving to the demand temporal distribution profiling is another type of segmentation. We can also see here the different groups. In this case, we have 6, and we can also see the different KPIs of each group. And the last profiling is related with the socioeconomic profiling. In this case, we only have 2 groups. We can also see the details per group. I don't know what's happening here. Okay. Moving to, for this prosumer, we do not have data. We can select this prosumer. Okay. And check this prosumer here, customers. Okay. Perfect. Here we have the details of this customer and the different KPIs. We can also check by different time periods. Moving to the wholesale market, here we have the historical deviation section where we can check the deviations between our forecast and the different historical registers. So in this case, for example, we can see the different upwards and downwards regarding the energy demand and the forecast. We have another section, but right now it is hidden because we are not working in live with live data. But when it will be available, we are also be doing this in live each hour. Okay, so the final user could be checking each hour the different upwards and downwards in terms of the real forecast. Moving to the market positioning, this functionality has been implemented by another partner called Urban from Spain. And here we are trying to predict the different prices in terms of, let me show you. For example, we don't have available data here. We're trying to predict the different day ahead, intraday, and continuous intraday prices, just to have a better idea, of how the prices will be during these 3 different markets. And moving to the last section, which one is called PPA optimization. This section has been implemented by another partner called Cuerva from Spain too. And here we're trying to provide PPA optimization, as the name says. Here we have three. For example, if we move to this test, we can see the different parameters that we are trying to optimize to achieve the PPA that the user has defined by these parameters. And we can also create a new one, just checking the parameters to optimize and clicking here. We are invoking the process to create this optimization. And this is pretty much the live demo. Moving to personalized energy analytics application. In this case, we're trying to targeting prosumers building users. In this case, the main focus tries to provide and enhance information about the energy usage habits and hints that encourage better behaviors towards more sustainable economic and environmentally energy demand patterns. We're trying to provide also advanced services for optimal operation of a smart appliance towards enabling a proper balance between comfort and energy savings. We are also trying to forecast the energy demand and the generation for the next month using deep learning techniques to provide a better energy usage knowledge. And also to remark here that this application is available from mobile devices. Okay, so I'm going to show you the live demo. In this case, you can see the aspect is different than the other ones. Here, this application is developed by mobiles. Now, I'm logged with my user credentials, which ones are related with FIP company from Austria. In the main view, we have the dashboard. We can see the current month indicators in terms of demand and generation. In this case, we are not having live demo, so we cannot show the current demand because we don't have registers, but we are displaying the forecast of the next month since the last available data. This is the forecast and also the total expected in terms of the forecast, and the same with the generation. We can see here the graphs. If we are working with live data, we can see here the real values since till the moment. Okay, moving to the next section and the energy indicators. Here we can see different historical data in terms of generation, demand, and also with the generation surplus. We can also check the self-sufficiency and the self-consumption. And one donut chart here. The next section is similar with this one, but with the difference that we can compare the values with previous periods. Okay, so for example, if we select this time period and we say that we want to compare the values of this selected period with the values of the previous week, for example, we are seeing here the demand value compared with the previous demand value of the previous week, and we have the more or less the same graph in terms of demand, generation surplus. Okay, perfect. So moving to the contracted power analysis here. Moving to April, we have data here. We can see an histogram that is displaying the contracted power analysis by the line, and also the use of our contracted power. So here we can see that we are not surpassing this contracted power analysis, so we are receiving good alerts that if our usage of power will superpass the contracted power analysis, which is not the case, we will be advised by these different alerts. Moving to, first of all, before going to the alerts and tips section, I would like to show you the settings view, which ones is opened as the first login of the user, just to let the user configure different thresholds, just to let the alerts and tips service calculate this type of alerts and services. So the user can define different daily demand threshold, also weekly and monthly, in terms of if the daily demand is over of this threshold, the user will receive an alert, and the same for the generation. Okay. So moving to the alerts, moving to wait period, for example, here we can see that our application is alerting the user that in this date, in the weekly granularity, the load energy was over in terms of the defined weekly threshold. We move to the other ones, we have more alerts. And moving to the tips is pretty much the same, but trying to give positive advices or negative advices to the user, just to let him be aware. Perfect. Moving to the smart home dashboard here. Right now, we are not displaying values because we do not have available live data, but we are also we are already displaying the available sensors in the user home. Okay, here this user only have configured 6 sensors, but we are moving to the monitoring section here. We can also see the different historical data related with this sensor. For example, if select the ambient decimer and we want to see, for example, the humidity, and move to this, for example, time period, we can see the different values, and the same for the different sensors. Okay, moving to the last section, which one is the smart asset scheduling. Here, what we did is we have created a comfort profiler just to try to forecast the different behavior of all the actuators in the user building. In this case, we only have 2 actuators configured, the HVAC for the bedroom and also for the dining room. So every day we are trying to forecast the next 24 hours behavior of this actuator. In this case, for example, if we click the HVAC, we are telling to the user that which will be the normal temperature of his house in this case, and in the next future steps, maybe we will let the service to activate automatically the actuator. In this case, we are only displaying the scheduling, but we are not activating automatically the scheduling. And also, we let the user configure different manual schedules of each actuators. Okay. This is more or less my presentation. I'm going to leave the floor to Costas.
Hello also from say. Thanks, Sergi. So the remaining 2 applications of this tool suite target mainly the aggregators and the way to ensure that the flexibility framework will be established, ensuring the active participation also of the prosumers in this process. And thus, we have established a marketplace environment targeting, as you can see here, prosumers and aggregators, on the way to ensure that prosumers with their flexible assets will be able to enroll into this marketplace environment, offer their flexible assets, and therefore be able, through a plug-and-play process, to have a contractual agreement with aggregators in order to further participate in flexibility services provisioning. Through this marketplace environment that has been established in the project, we ensure that both entities are accessing this environment, be able to proceed with a contractual agreement, different steps of this process that are going to be displayed later, in order to ensure a common agreement among both entities. And once this contractual agreement has been established, and each flexible asset may participate in different flexibility service provisioning, we ensure at the end that a fair settlement and remuneration process is established on the basis of standardized measurement and verification methodologies, in order to ensure that at the end, each flexible asset is promptly remunerated for the provision of the different flexibility services. In order to ensure fairness and transparency in the overall process, we have established a blockchain network where the different results of this framework, the contractual agreement, as well as the results of the remuneration process, are stored to this blockchain network, enhancing that way the overall transparency in the process. We are now gonna proceed with a live demo of this application. So this is the view for the marketplace environment. As it's evident, there are two different stakeholders entering this application. Thus, you can see the screen with the aggregator view and the flexibility asset owner view. Starting with the view of the flexibility asset owner, once the user is entering into the application, he or she can get access to the list of assets that are part of his or her portfolio. For this user, you can see that we have two different assets available, a demand-side asset, which is an air conditioning system, and a storage unit, which acts also as a flexible asset in Synergy project. The user has a filtering view where he or she is able to get a view and a filtering view on the different types of assets based on the typology that we are considering in the project, the location where the asset is placed, as well as considering some energy and flexibility related characteristics for the characterization of the different assets, the nominal power, the flexibility capacity of each asset, as well as the reaction time for participation of the different flexibility services. For each of the assets, the user is able to drill into the details, get insights about the nominal characteristics of this asset, get market availability details where the user is able to enable or disable participation to the marketplace environment, enable the number of activations to be triggered to a specific asset, as well as set a schedule for enrollment at the different flexibility services. Along with the history of the information, the user is able to filter over a specific period in order to get insights over a period for further analysis. Once the user, which is the flexible asset owner, enables participation to the marketplace environment, then the asset is available to this view where the aggregator is entering and can get access to the list of flexible assets that are eligible to be part of a contract. Similar to the user view, the aggregator can access the list of assets, get insights for each of the assets, again getting details about the nominal characteristics, the market availability details, as well as the flexibility timeline, as you can see below, and further be able to proceed with a contractual agreement. In order to do this, he or she first has to select the asset and proceed one or more assets, get a view on the card, and proceed with the creation of the contract. In order to create a contract, we have established in the project a standardized template where the aggregator who is initiating this process has to provide details about the operational status of the contract, the start date and the end date of the contractual period, putting some numbers here, the maximum flexibility capacity that is under the contract, the number of daily activations, as well as the number of the total activations. In addition, financially related parameters having to do with the remuneration of the assets are provided, highlighting a remuneration process for the utilization of the flexibility, for the availability of the asset to get enrolled in flexibility services, as well as a penalization in case of non-conformity. In addition, availability details having to do with the specific time frames where the asset is to be utilized are further specified as part of the contractual agreement. Once the contractual agreement has been established, the contractual template has been filled in, then the contractual agreement is to be established by providing the password for the wallet, for the blockchain wallet, in order to have this let's say contract details to be registered on the blockchain network. This process takes a while in order to have this transaction mined to the Ethereum wallet. and then the contract has been sent to the relevant user. Once this process has been done, then the flexible asset owner is getting in the list of contracts, as you can see here, the different offers that have been triggered by the aggregators. For this specific offer that has been triggered by the aggregator, the user can enter into the details of the contract as this has been established through the contractual process, and proceed with 3 different actions. The user may accept the contract offer, may decline the offer, or even further negotiate specific terms as provided in this template. By declining the offer, the user is again prompted to provide the details of the password for the Ethereum wallet. And then we have either the finalization of the contractual process or further negotiation if this is needed. Similar view is available also from the side of the aggregator, where the aggregator is able to see the full list of contracts, search a contract with specific filtering parameter, or sort the contract based on specific characteristics. Following the activation of the contract and the participation of the asset into different demand response campaigns, as we said at the beginning, we offer also the settlement and the remuneration for the participation of each of the asset under a contract into different demand response campaigns. This view, the settlement and the remuneration, is also available for both entities, for both aggregator and prosumer, indicating some KPIs, some insights about the participation of each of the specific assets that is under a contract to the different flexibility services. As you can see here, under a specific demand response event, we get insights about the requested flexibility, as well as the amount of flexibility that has been offered, plus details about the remuneration, the financial remuneration of this specific asset under this specific demand response event that has been triggered into this under this contract. Complementary to this application that has to do with the establishment of the marketplace environment and further settlement of each flexible asset under a contract for participation into different demand response campaigns, we have the view of the aggregator during the actual enrollment of each asset into demand response campaigns. So this is the second application that is named Flexibility Analytics and Consumer-Centric Demand Response Optimization, where the aggregator, once a contract has been established, get access to the management of the asset that is under the contract. The user is able to get insights about the flexibility potential of the asset that now is part of his or her portfolio, is able to proceed with clustering techniques in order to set proper VPPs, virtual power plants, that will facilitate the aggregator to participate with pools of flexible assets into the delivery of grid services for network operators. In general, the aggregator may offer the flexibility under different services, but under the context of synergy project, the main target is the provision of flexibility services for the needs of grid network operators. And then, once there is a need for flexibility activation, so once there is a need from the side of the grid, a demand response event is accepted from the grid operator, and then this is disaggregated, the different flexible assets that are part of the portfolio, in order to further enable the demand response activation. For this view, for this application, we're going to have the second demo. So again, entering into the application with the role of aggregator, the user is able to get access on the list of flexible assets that are under a specific contract with this aggregator. So this is the linkage with the previous application in order to showcase that a contractual process needs to be established first in order to enable activation for a specific flexible asset. The user is able to filter again the pool of assets that are part of the portfolio under different criteria. similar to the criteria that were presented before in the marketplace application. So the user is able to select the asset type, the location where the asset is placed, the nominal characteristics of the flexible assets that are part of their portfolio, as well as flexibility related criteria. In addition, business properties are made available as part of the search functionality, incorporating in this filtering analysis the contractual details as established in the previous step, the previous application. The user is able again to get insights about the performance of the asset, similar to the previous view. Details of each asset are available, and the user is prompted to set a filter, select a period for fine-grained insights over the performance of each specific asset. And then the user is able to select one or more assets in order to create a cluster. Apart from the manual selection of the assets for creation of a cluster, the user is able to utilize the ML-based. So we have incorporated some AI-based techniques in order to provide automated clustering under different scenarios, and based on the performance of each specific asset, the user is able to apply some clustering techniques, and then being able to again select the assets that are able to be considered as part of a new cluster creation. In order to create a new cluster, the user is able to select the title and description, and from description characterize the asset, the cluster of assets that will be part of the VPP configuration. Once this configuration is performed by the user, then the view of the cluster is available, indicating different business orientations for the aggregator through these VPP creations, where the user can get insight about each specific VPP, being able at any moment to manage the list of assets that are part of the clusters, edit the details of the clusters, or even further delete the cluster. By pressing each of the clusters, then the user gets insights about the flexibility potential of the cluster and of the assets that are part of the cluster. The very last functionality that's available through this view, so now the data are loading, we're loaded in order to view insights about the specific cluster. So once the cluster has been established, for example, VPP1, the aggregate flexibility potential of each cluster is made available to the flexibility marketplaces. In our case, as I said before, the flexibility potential is made available to the network operator in order to further utilize the available flexibility for a grid-related service. So once there is a need from the DSO, from the network operator, a demand response event is triggered by this entity and is accepted by the aggregator through this application. Here you can see the view of the different demand response campaigns that have been triggered by the network operator. Sorting and filtering functionalities are also available in order to sort and filter the different campaigns that have been triggered by the network operators if needed. And then we have the details of this network event that has been triggered, indicating the start period and the end period for this demand response event, as well as the number of the amount of flexibility that has been requested, considering also the allocation of this event at the different timestamps. Once a demand response event has been triggered by the network operator and has been received by the aggregator, then the optimization process of this application is running in order to further allocate this network request to the different flexible assets that may offer flexibility and are part of the portfolio of the VPP configuration. Details about this distribution, this disaggregation of flexibility are displayed through the screen, where for the different assets, we can get insights about the flexibility that has been allocated for this specific event to the two assets that are part of the configuration. The user is able to get insight about the performance of the different assets under demand response event. Similar information as was displayed before through this through the marketplace application, and also the user is able to remove and delete the strategy that has been triggered in the past. That was the last view of the application for the aggregators in order to manage the portfolio of the assets that are part of the of the configuration.